zeros on this side for some reason. So let's wait a bit, maybe. That clock is a bit fast. It's not yet 2:05. Anyhow, can you guys in the back see the screen? We're in a different room today, in case you did not notice. It's just different, right? Sometimes the board is a little smaller, which might mean I have to erase it more often. How is assignment 2 coming along? We have about a week to go. Questions and comments or anything you want to talk about before the start of the lecture portion today? So everything is going well, I assume. Maybe. Alright, so maybe let's get started. Probably don't have other people joining us. The main idea of today's lecture is going to be about object-oriented programming, except we're going to be doing this in the context of functional programming. I don't know exactly how to introduce it, so I'm going to use a case study to discuss this. We're going to be implementing a data type to support rational numbers. And then I'm going to be talking about things like operators, and we have some philosophy discussion at the end, just to close this lecture. Okay, just to remind everyone, a rational number is what? Anyone knows what a rational number is? Yes?
A number that can be expressed as a fraction.
Fraction of some kind. So basically x over y. Any restrictions on what x and y might be?
X and y have to be whole numbers.
They have to be whole numbers, right? Otherwise they make no sense, because then you could do a pi over 1 or something, and then that would not be true to the spirit of fractions. So we kind of insist that these things have to be whole numbers. And then once you have this thing, you can add them, right? You can add two rational numbers together, you can multiply them. One thing before we move on. So let's say I have x over y plus p over q. We'll come back to this. Do we know how to add them? Just try to remind ourselves from maybe middle school or something. Okay, so that's all we need for today. The question is, in our program, how might you keep this kind of data? So suppose I want to design a data type called rational. How might I do this? Any thoughts? Based on what you guys have learned and seen, how might we keep this thing? Case class. So you can do something like case class rational, maybe P is something, Q is something, right? You can do that. What else? What are some other possibilities? So case class has the benefit of knowing exactly that the first one is going to be called P. The other guy, the denominator, is going to be called Q, right? There's something more generic and more primitive we can use as well if you want to go that route. And that's the idea of just defining a pair, right? You can encode x over y as a tuple of size 2. So it's a tuple int comma int. And then because you want to be able to say that this is rational, you can say, oh, I'm going to create a type alias. Rational is defined to be a pair of int comma int, like so. Make sense? So these are two ways to, at least two ways to represent such a data type. Now, what does it take in each of the cases there to write a function that says, suppose I want to add them together? So here is one rational, here's another rational. What do I do to add them? Well, just pick one of them, right? Which one do we want to play with? Top or bottom? Top one? Okay, so let's go with the top one. How do I add these two rational numbers together? So it helps to kind of remind ourselves how to add two rational numbers. What do we get? Without trying to normalize it or reduce it to a lower form, we're just going to multiply the denominator together and then what? Some cross multiply motion. So what do we do? X times Q plus Y times P. Question is, how do I write such a thing in Scala? There are a couple of routes we can proceed now, right? You can go with P dot underscore 1, P dot underscore 2, Q dot underscore 1, Q dot underscore 2. If that is too bad for your eyesight, you can try to unpack it using things like val. So you can try to unpack it so that you get x and y, or maybe let's call this numerator 1, denominator 1 equals to p, and you can do numerator 2, denominator 2 equals to q, right? And at this point, you can compute this thing and then return it properly. In this way, your expression might be more sensible than doing P dot underscore 1, so on and so forth. Okay, good. Ultimately though, I want to be able to do things like, here is rational R. T is also rational. I should be able to just say R plus T, like this in code. That's kind of the ultimate goal to get. What we have right now doesn't allow us to do this, right? I can't quite say, okay, here's rational, let's add them together without calling the function add. I can't just type in plus. So something is still missing. Also, I should be able to look at R and make this thing show up in some nice way to say 3/4 or something. We don't have this, at least not yet. So these are some missing features that I would like to have. Now, you might remember from a couple terms ago when we started learning about object-oriented programming that thing can make our head spin in different ways. At the same time, it gives us a very nice way to structure our code. It also shapes our thinking in some very special ways. So we'll look at the third approach, where in addition to defining a type alias, creating a case class, we're going to try to create a class from the ground up. So think of this as like defining your own class in Java, except what we're doing now is in a different language. So here's what I'm going to do. I'm going to attempt to define a class called rational. And this class is a very simple one. So what I've done so far is I'm defining a class with that name. Now, what I want to see inside is I want it to be quote unquote exporting two attributes. One is called numer for a numerator. I'll come back to what that is, but you can guess what it is, right? The other attribute I'm going to be writing is an attribute called denom for denominator, basically. But like we need to store or at least take in the numerator and the denominator from somewhere. And the place where that's going to happen is the following. I am going to say, okay, rational you're going to take in and you're going to take in d. These are two different parameters. And for numer, it's just going to be n. And for denom, it's going to be d. This nice little piece of code, when added to the REPL, is going to do two things. One, we have created a data type. The name is rational. It comes because we have defined a class. The other thing that happens right here is we have a constructor for this class. It doesn't look like it, but if you pay attention, very close attention to it, this thing looks like a function, right? A function that accepts two arguments, n and d, and then what it returns is something like numer and denom. So you can think of this as a constructor. So really it is a constructor. So we're going to try to use it like so. Val, new, rational 3,4. If I hit away from you, val, you might feel like I'm doing Java because it looks the same. Also, let's try another one. The top version says, let's define a variable r, which is equal to new rational something. The bottom version says, I'm going to create rational 1,2. The only difference is new is not there anymore, right? It turns out that in scalar 3, new is optional. So when the context is clear, you can drop this new. It knows somehow that they have to call new. If you want to put new there, it doesn't hurt anyone either, so up to you. Now, just like before, I can go r dot something. If I hit tab right now, you'll see autocomplete doing its work, meaning that I can try to access denom, I will see 4. I can access numer for numerator, I will see 3, right? So dot notation works just like you expect it to do. Okay, so nothing fancy here. The same goes with s, okay? Which brings us to the first few remarks regarding how classes work. Things inside the class is going to be public by default unless you say otherwise. Okay. Number two, we have this curious looking rational add some random stuff, right? What does that remind you of? Does that remind you of something? It reminds you of what again? It should remind you of your very own classes from data structures before you implement toolstring. So it is the kind of class without a toolstring method, meaning that it doesn't yet know how to display the info properly. So this is the default toolstring. It says, I am the rational class, and this is my hash code. More like the memory address where this thing appears, right? So that's another thing that I want to change. I want to be able to say R, which happens to be rational, and instead of showing rational at some random stuff, it should say 3 over 4. Okay, so that's something on my to-do list. But before we try to do that, let's implement a function together. More like a method, really. What I want to be able to do, at least for now, is I understand that writing R plus S or R plus T is more natural. But right now, as an intermediate step, I would like to be able to do R dot add S. Make sense? And what should result from here is the result of adding R with S. So this is an example of a method implementation inside a class. What do you think we need in here? If this were Python, what do you need? Some notion of self referring to this instance of the object, right? In Java, what do you do? Just the actual argument, right? Scalar goes with the same approach. So this is how you say you want access to that other thing. I chose the name that because there is this object, our very own object, referred to using the keyword this. And the other guy, which we're going to be adding ourselves to, is going to be called that, okay? What do I do? How do I accomplish this? Oh, by the way, what should we expect as the return type? Nothing other than rational. Makes sense, right? How do we actually implement it? I mean, I know I want that logic, but exactly what do I type? Okay, I'm going to do it like this. There is going to be this bit of expression and that bit of expression. So 2 lines of code. The bottom one is going to be exactly this logic. The logic for denominator. And that one should be really simple, so tell me what to do. This dot denom times that dot denom. Are we in agreement that that's how to compute the denominator? What about the numerator? This is numer times that dot denom plus. Okay. Now that we have all the pieces, how do I return rational, irrational? Here's a first attempt. We can try to create a tuple, like so. The problem is what? Or is this good? No. What we're returning right now is a tuple of int, comma int, but we expect to see what? A rational. So how do we create an actual rational instance? If you prefer to be super explicit, you can say mu rational. If you grew up on Python's kind of land and you prefer it this way, then go ahead. Now that we're at it, let's also do multiply. Let's give ourselves 45 seconds to implement it. 2 minutes. And now you know that it has to be enclosed in a rational constructor because you expect to return a rational. And while I'm writing this code, I want to point out that when you call add, for example, r.add of s, r remains untouched, right? S remains untouched. What happens at this point is the computation happens and you return a brand new rational. So we're still functioning in a functional kind of way. Okay, good. What do we write inside this parenthesis? This dot here times comma denom times that denom, right? So it is as simple as that. Let's see what we got. R is rational leaf water. S is rational 1/2. R at S. Oops. Wait. Did we add up the numbers correctly? We don't know. I can store this inside T and I can inspect it. But wouldn't it be a lot more convenient if I could just see the result? What do I need? Any guess? Back in your good old Java days, you had to write a toString method, right? So we're going to do that. To make this humanly readable, we need a toString method. And like in Java, I want to be explicit that I'm about to override something. So this is what I'm going to say. toString. What do I do? I can do a fancy string formatting notation, but I'm not. So I'm just going to go ahead and do this lame something plus something plus something kind of exercise. try this again one more time. Interesting. So it seems like this feature is now done, right? Checked. This feature is also implemented. So we got these two features. Here's something that's kind of nagging me right now. Maybe it just annoys me. I don't know about what about you. So when I add R and S together, what I realize is that it says this is 10 over 8, right? But 10 over 8 is also known as 5 over 2. It's not in the lowest form. Is there something I can do to guarantee that whatever comes out of this is going to be in the lowest form? So 10 over 8 is not in the lowest form because if you remember something from middle school, you remember that I can divide both the top and the bottom by 2, right? And this thing will be 5 and this thing will be 4. Yes. What do we need to do? Seems I need two things. One is to realize that the greatest divisor common between these two guys is 2. And divide through by it. Right? What is this thing called? It has many names. I usually go by the greatest common divisor. How do we find such a thing? Can we find it? I want to write a function called GCD. You probably saw this back in 101. There is a very efficient algorithm for finding the GCD between two numbers. Kind of goes by the name of the Euclidean algorithm after Euclid from the ancient Greek, right? Now, how does it work? It is recursive, so you can easily write this in Scala. If b is 0, what do we know? It turns out if b is 0, I know that a divides both of them. So the answer is a. Otherwise, it turns out, according to Euclid, we can just do this. Good? I'm not going to try to explain why GCD works. It's just that this is the Euclidean algorithm, which you have seen already from 101, and you will learn more about it in another class. Meaning, you can analyze the running time of this in algo, but we're not going to talk about it now. Anyhow, one thing I want to do is GCD is very specific to rational, and I don't want anyone else to be able to use it. How can I hide it from other people? What keyword, if you happen to remember from Java, did we use to say this stuff should not be seen by other people? Private. Guess what? That's exactly how we make it so in Scala. So we say private, define GCD to be blah blah blah. And in this way, GCD would not be visible to be outside. It's private to this class. Now, I feel like we don't need to be computing the GCD again and again and again every time. So I'm going to do it once and for all. And I'm going to store it in a variable called G for GCD, for the greatest common factor. Note that it is important that we're using a val as opposed to a def, right? Otherwise, every time I refer to G, it's going to compute it again. And what can I do here? I can divide through by G. Yes? And in this way, every time we look at numer and denom, you're going to see it in the lowest form. Of course, you have some other choices because right now, every time you call numer, we have to do this computation. Maybe you don't want that, right? So go ahead and change it however you like. So this is how it looks right now. I'm going to copy and paste this onto the repo and see what we can do with it, at least for now. Val, rational, question. I want to add R, S, and T together. How do I do that? Right now, what I did was R dot add, right? And what happens at that point is R and S I added together. How do I continue my chain of actions? By adding T to it as well. It turns out nothing stops you from doing this, right? Because if you think about it, the result of R dot add of S, this thing by itself, is a rational. So you call dot add on it. So tacking T to it doesn't hurt, and this is what happens. Quite interestingly, you see 1 over 1. It's yeah, it's the right thing. Any questions so far? Let's get a bit fancy, since you guys don't have any questions. What if I want to do 5 over 1, meaning I just want the number 5, right? Is it possible for me to just write this, knowing that the default is going to be 1 on the other side? Right now, no. What can we do? You can look into setting a default value for some argument. I'm gonna use this opportunity to showcase another feature, which is you can have another constructor and alternative constructor. So this is an alternative constructor. You can define something here, which, wait, what should be the name of the constructor? There seems to be two schools of thoughts. One is just use rational because that's the name of the class. While very rational, as the choice of name is very rational, when you change the class name, you have to change this as well. Another school of thought is to use an agreed upon keyword which will not change with the class name. Turns out, Scala decided to go with this. Meaning the keyword this. On the right side, if you change this class to some other name, you don't need to change it. How do I refer back to the other constructor? Amazingly, this is how. In the same sentence, I'm going to be saying this too many times. We're defining this with n taking in as a parameter, and then we're going to call the other constructor, which happens to be called this. Yeah. Good. So at this point, I have a data type capable of taking in either a fraction, x over y, or a lone integer, which once it detects that, it says that's just that number over 1. It will always keep this thing in the lowest form thanks to the GCD function. We're able to add two rational numbers together. We're able to multiply two rational numbers together. We have a two-string function which will render rational numbers in a nice form. Okay, so this is where we are at the moment. The plan going forward is we're going to take a break, let's say 5 minutes. When we come back, I want to talk about this. Right now, this is how we add two rational numbers together. But what I would like to be able to do really is, instead of writing this, I want to be able to say r plus s, and then if you really want, plus t also, right? So this will happen when we come back. What time is it? 2:41 right now, so 2:46 is when we're going to resume.